I am going to do a quick recap of Friday's lesson here to remind you about rational numbers and irrational numbers before we move on to using those. So rational numbers are numbers that can be written as the quotient of two integers. So remember we talked about how they could be written as fractions. So think about it, every integer, which is positive and negative whole numbers, all whole numbers, and all natural numbers are rational numbers. So they all can be written as a fraction. So if I gave you the number 3 and asked you to write it as a fraction, you could simply just put a 1 underneath of it, and you would have 3 over 1, which is equal to 3, but it's still written as a fraction. Okay. So the other thing I wanted to point out here in this example is right here. The square root of 25 is equal to 5. So don't just automatically see that square root, that radical symbol, and automatically think it's got to go on that left-hand side of that chart because it has a radical symbol. Look to see if it's a perfect square first, which means it has a whole number answer. So in this case, the square root of 25 is 5, so it fits actually on the rational side because 5 is rational. Okay, and I just talked about this number line here. The square root of a perfect square is also a rational number. So these are the first 4 perfect squares. We can take the square root of them and get whole number answers. Also take decimals as long as they're terminating and write them as a fraction quite easily. You just read them correctly. So 0.4 is really 4/10. So that means 4 over 10, and then you can reduce that to 2/5. So here's a few examples of how you can take a decimal and write them as a fraction and then reduce them. Now, if they're repeating, they're still fitting under the rational category, but remember I showed you how to write them as a fraction using this solving method here. So you could draw all that out, or you could look at right here, 3/9 is equal to 0.3 repeating. So if you looked carefully, 3 was our decimal that repeats. So 3 got to be written as the numerator of a fraction. And then that 3 is actually in the tenths place. And if we take 1 less than 10, we have 9. So that's where our denominator came from. So there's a little bit shortcut method for you instead of doing all of this solving over here on the left-hand side. So same thing here. We did this one in class and in our notes last Friday. We have 512 is the repeating decimal. So that would be your numerator. And then tenths, hundredths, thousandths, that 2 is in the thousandths place. And if we take 1 away from 1,000, we have 999. And that's exactly the same answer they got. So a little bit of a shortcut for you instead of writing out all of that work. All right, so what fraction is equivalent to 5.1? And is 5.1 a rational number? So it's actually, if you read 5.1 correctly, you would say 5 and 1/10. So that's exactly what you would write. 5 as a whole number and then 1/10. Is it a rational number? Yes, because we could write it as 51 over 10. So we can write it as a quotient of 2 numbers. Explain, I just did. We can write it as a fraction. So remember, all rational numbers can be written as a fraction. So I won't take too much time writing out my explanation, but I would like you to explain yourself as best as possible when you're asked to explain. All right. Number 2 here says, look at the number line below. The number square root 2 is between the square root of 1 and the square root of 4. Since the square root of 1 is 1 and the square root of 4 is 2, that means that the square root of 2 must be between what 2 integers? Well, it has to be between 1 and 2 because if I continued writing this, I would have the square root of 2, then I would have the square root of 3, and then 4 is already there, and so on. So the square root of 2 would be right about there, according to our number line. So integers, remember, are positive and negative whole numbers. So the answer to square root of 2 has to be between 1 and 2. Number 3, draw a point on the number line where you would locate square root of 2. And where did you draw the point? I just did that for you. And where did we draw it? We drew it closer to 1, but between 1 and 2. And then number 4 wants us to calculate these numbers. 1.3 squared, 1.3 times 1.3, and you get 1.69. And then 1.4 squared is 1.4 times 1.4, and you get 1.96. And then 1.5 times 1.5 is 2.25. Now, if you think about it, 13 squared, 13 times 13 is 169. 14 times 14 would be 196. And 15 times 15 is 225. So that might help you remember what numbers you should be working with. And then remember the rules for multiplying with decimals. If I multiply this, I know 13 times 13 is 169, but I have one decimal place here and one decimal place here, which means I'm going to have 2 decimal places in my answer. That's just reviewing multiplying with decimals. Then number 5 says, based on your calculations, draw a point on the number line below where you would now locate the square root of 2. Where did you draw the point? So we have square root of 1 and the square root of 4. We have 2 and 3 in between there. So the square root of 2 might be here, and then the square root of 3 might be here. Oops, 2, because we have to divide it up into fourths. So somewhere in this area here. Now calculate 1.41 squared and 1.42 squared. So 1.41 times 1.41 gives us 1.9881, and then 1.42 times 1.42 is 2.0164. So based on these calculations, the square root of 2 is between what 2 decimals? So it would be between 1.41 and 1.42, because neither one of those gave us an exact answer of 2, but one was just a little under and one was just a little bit over. Number 8 says you can continue to estimate getting closer and closer to the value of the square root of 2. For example, 1.414 squared is 1.999396, and 1.415 squared is just a little bit over 2 at 2.002225. But you will never find a terminating decimal that multiplied by itself equals 2. The decimal will also never have a repeating pattern. So this leads us into irrational numbers. This means that we will never be able, no matter how hard we try, never be able to find an exact answer to the square root of 2. So anything that's not a perfect square, so those numbers that we can take the square root of and get whole numbers, so like the square root of 9 is 3, anything that doesn't work out like that is going to be referred to as an irrational number. And an irrational number cannot be written as a fraction or a ratio. And irrational numbers go on forever and they never repeat. So that is a good point to remember. So go on forever and never repeat. So things like pi. Pi goes on forever and never, the decimals never repeat themselves. So there's no pattern there. So that would fall under the irrational numbers, okay? All rational numbers and all irrational numbers make up our set of real numbers. So if you remember back to Friday, I gave you that number chart, and we had rational numbers on the left-hand side and irrational numbers on the right-hand side, but that whole chart was called real numbers. So everything here is a real number. And then for our last question, number 9, the value pi is a decimal that does not repeat and does not terminate. Is it rational or irrational? We just talked about that. It's definitely irrational. And explanation on that is it goes on forever and never repeats.